Hello everyone. So you can see there are two problems. Okay, one is peak index in a mountain array, and this problem is asked in Amazon. Okay, there's another problem, find peak element, and this problem is asked in Microsoft. Okay, and the beauty is both problems are same. Both the problems are same. Okay, and we will write just one solution for both the problem. Not a single chain we will write. Just one solution we will write, and we will paste that complete solution in both the problem. Okay, and we'll got our answer. And this is why this is the beauty of this course. This is the best DSA course which is freely available over YouTube. Okay, because we want you to build the intuition. Okay, so let's see the problem. The problem saying us that peak index in a mountain array. Okay, so you can see this is the mountain array, and the best way to understand what is mountain array is, let's create a mountain. Okay, and then represent this array elements in the mountain 0 1 0. Let's create a mountain and represent this element in a mountain 0 2 1 0. And what we need to find this peak element index. Simple. This is what mountain array, and also we call it as a biotonic array. You are given an integer mountain array ARR. Okay, ARR is given to us of length n, and where the values increase to a peak element and then decrease. Okay, that means similarly like mountain, when mountain increases and then decreases. Okay, similarly the array is given to us 0 2 1 and 0. This is the array. Okay, so initially value increases and then decreases. That means 0 2 1 and 0. This is what the mountain array. Okay, we usually call it as a biotonic array. Okay, so he want us to find out the peak index. That means this 2. Okay, this is the peak. Okay, in this case 0 10 5 2. Okay, he want us to find out the peak element. Okay, so let's see the example in our whiteboard. If suppose the array is given to us as 0 10 5 2. Okay, so let's draw this in a mountain. This is the mountain 0 10 5 2. So he want us to find out the index of this peak element. Okay, another example is suppose 3 4 5 1 2 and 1. Okay, so let's draw this in a mountain 3 4 5 2 and 1. So he want us to find out the index of this peak element. Okay, so this is what we need to find out. And one thing I want you to notice, that suppose the array is given to us 3 4 5 2 1. Okay, so in mountain array one part is increasing and another part is decreasing. Okay, it is increasing and it is decreasing. There are two parts present, one is increasing and one is decreasing. Suppose the array given to you is 3 4 5 6 3 2 1. Okay, so you can see this is the increasing part and this is the decreasing part. Okay, so this is what a node point of mountain array. You can see how mountain increases and then decreases. Okay, so now let's proceed how we will find out the solution of the mountain array and the problem, both the problem one solution. Okay, let's proceed. We'll proceed. It's very simple. Okay, and it is a medium category problem asked in Amazon. Fine. So how we'll proceed? Suppose our array given us 3 4 5 6 4 and 2. Okay, so let's draw this in a mountain because it is mountain array 3 4 5 6 4 and 2. Okay, and we need to find out the peak element index. What is the peak element? 6. Okay, so we need to find out the index of this element. Okay, so now how we'll proceed it? Okay, whenever you see a complex problem of binary search, okay, first you need to just divide that binary search problem into the different cases. Okay, now you will be asking, right, what are the cases, like how we will divide. So we will see later what are the cases and how you will proceed. First let me show you that why we are using binary search in this. Okay, why we need to apply. So there are two green flag. One is, you can see, log n. O of log n. Okay, O of log n time complexity. So he want us to use O of log n time complexity. That means binary search. Another is sorted array is given 0, 10, 5, 2. Okay, you can see it is increasing. That means it is sorted, and decreasing. That means it is sorted. So binary search is confirmed. Okay, so binary search we need to use it. Fine, that is confirmed. Now how to solve this problem? Binary search is confirmed. So if binary search is confirmed, that means start index and end index. Okay, this is, and index are 0, 1, 2, 3, 4, 5. Fine. So I have told you that you need to just divide the problem in a cases. Now what are the cases? Like how you will define? So cases means try to get how we will get the solution. Try to find out those cases how we will get the solution. What is the solution? Peak index of the peak element. Okay, what is the peak element? 6. There should be only one peak element in the mountain array or biotonic array. So you need to calculate like that how we will get this element index. Okay, so the cases are, there's a two cases. The first case are if ARR of mid. Okay, suppose we have calculated the mid. Okay, we have calculated some mid. Okay, so now if ARR of mid is greater than ARR of mid plus 1, if suppose my mid is 6, so let's take the array here 3, 4, 5, 6, 4, 2. Okay, so in this case, if ARR of mid is greater than ARR of mid plus 1, that means suppose if my mid is this, okay, that means we are in the decreasing part of array. If this condition got true, how? See here, if my mid is this, if my mid is greater than the next element, that means I am decreasing. Okay, if my mid is greater than mid plus 1, that means I am decreasing. Okay, so if I am decreasing, that means I am decreasing part of array. So this is the first case. Okay, my start is this and end is this. Okay, the second case, if my mid is greater than or less than, if my mid is less than ARR of mid plus 1. Okay, if suppose my mid is 5. Okay, so let's take another case 3, 4, 5, 6, 4, 2. Okay, suppose my mid is 5. Okay, and in this case, if my mid is less than, if my mid is less than the next element, that means in this array, in this case, okay, that means we are in the increasing part. See, if my mid is less than the next element, that means we are increasing. Okay, because my mid is less than the next. Okay, so it is less and the next is bigger. That means I am the increasing part of array. So if this condition got true, that means I am increasing part of array. Okay, so these are the two conditions we have drawn. Now what we need to do it to solve the problem. Okay, so what we need to do it, let's see. Next, so according to the first condition, if ARR of mid is greater than ARR of mid plus 1, okay, and our array is 3, 4, 5, 6, 4, 2. Okay, and according to this, we are in the decreasing part of array. We are in the decreasing part of array. That means in this case, end equals mid. This is the start and this is the end. Okay, I'll explain everything. And in ARR of mid, if ARR of mid is less than ARR of mid plus 1. Okay, so and if the array is given as 3, 4, 5, 6, 4, 2. Wait 1 second, what is the array? 3, 4, 5, 2, 4, 6. Okay, so if my ARR of mid is less than, that means we are in the increasing part of array. Okay, in this case, so in this case, start equals mid plus 1. This is start and this is end. Now why here E equals mid, means end equal mid, not mid minus 1 or mid plus 1? see here, if my mid is this, okay, then I don't know that is there any, see, let's understand using mountain. Okay, 3 4 5 6 4 2. Okay, suppose my mid is this. Okay, that means I'm the decreasing part of array. Okay, so an and is this, so I'm making my and as mid, because I don't know that is there any peak element present it or not, or it is the peak element or not. Okay, in this case you can see, in this case 3 4 5 6 4 2. Okay, if my mid is this, okay, and I'm checking that ARR of mid, that means ARR of mid is less than this. Okay, so our start is mid plus 1. Why? Because see, we want to find the peak element. Okay, we want to find the peak element, and we very well know that if this is my mid, then it is not peak element. Why? Because this condition is getting true, and when this condition is getting true, that means ARR of mid is less than ARR of mid plus 1. So we very well know the one note point that ARR of mid plus 1 is greater than this. Okay, that means our peak element should not lie here. Definitely it should lie in this part of array, because we very well know na ARR of mid plus 1 is greater than ARR of mid. So why we will check till ARR of mid? We can start checking then ARR of mid plus 1 to end only, right? So that is why start equals mid plus 1. But in this case we don't know that it is the peak element or the next is. Okay, get my point? So this is what the problem, and the else part we are returning a start. Okay, so now let's do the complete program. Okay, let's do a complete program. Fine. So the array given to us as 3 4 5 6 4 2. Okay, this is the start, this is the end. Calculate the mid. What is mid? 0 1 2 3 4 5. 5 upon 2, that is 2.5, which is 2. Okay, 0 1 2, so this is the mid. Okay, now check in both the condition. In first condition, the mid, what is the ARR of mid? ARR of 2, mid is 2, right? So ARR of 2, that is 5. 5 is greater than mid plus 1 or less than mid plus 1? 5 is less than mid plus 1, that is 6. Okay, that means we need s equals mid plus 1. So what is the start? Start equal mid plus 1. What is the mid? 3 2 2 plus 1, which is equals 3, which is the new start. So this is the start and the new start is this. Okay, again check. ARR becomes now the range, our range becomes 6 4 and 2. Okay, and this is the start and this is the end. Again calculate the mid. So mid is now start plus end upon 2. What is the start? Start is 3 and end is 0 1 3 4 5 upon 2, that is 8 upon 2. Okay, and 8 upon 2, that is 4. This is the new mid. Okay, the new mid is 4. So again check ARR of 4, which is equals 4 only. Okay, so this is 4. Now it is greater, less, or it is greater than ARR mid plus 1 or less than? It is greater than ARR of mid plus 1. What is ARR of mid plus 1? 2. ARR of mid plus 1, it is 2 only, right? This is mid plus 1, so it is greater than. If it is greater than, then and equals mid. Okay, so this is the mid. Now and becomes this. Okay, so now our updated range is only 6 and 4. Okay, because start is this and end become this. So updated array will remain 6 and 4, start and end. Now again calculate mid. So mid was start is start plus end upon 2. Okay, you can also write start plus end minus start upon 2, the same formula. So 3 and 4. 3 plus 4 upon 2, that is 7 by 2, that is 3 only. Okay, so my my ARR of mid. What is mid? 3. Okay, which is equals 6. Is greater than mid plus 1 or less than? It is greater than ARR of mid plus 1, that is 4. Okay, so 6 obviously greater than 4. If it is, then AND equals mid. What is mid? This is only mid. What is AND? Now AND becomes also mid. So after this case, S start equals AND equals mid. Okay, and when start equals AND, that is the answer. Return start. And what is the start? The start is 3. Okay, and 3 is answer. You can see when we have taken, so we need to find the peak element. What is the peak element? 3, 4, 5, 6, 4, 2. Okay, what is the index? 0, 1, 2, 3. Return it. 4 and 5. And this is the answer. Simple. Are you getting what I mean to say? So this is what we need to implement the same. See, I have shown you completely this problem using the visual representation. Okay, using mountain representation. Okay, using the steps. We have also discussed the steps. Okay, and we have also discussed each and every passes. Like it's in first pass, the array got changed here, and then the range got changed. Everything fine. Now the only remaining thing is, let's implement this complete thing into the code, into the Eclipse. Okay, and then you will see the same solution we will copy and paste. Okay, so now let me open my Eclipse. Okay, so now let's create a new project, Java project, and in that we'll give a name as a mountain array. Finish. Okay, it created mountain array. Now let's create a class. Fine, com dot mountain. Okay, and class is peak index in mountain array. Okay, now the first thing is, let's create a main method. Okay, and then let's create a method, get me index of mountain array. Okay, don't worry, we will also understand using debugging. Debugging is the best way to clear all the concepts. Now let's create the array. What is our array? Is 3, 4, 5, 6, 2, 4 and 2. Okay, increasing and then decreasing. Now let's create this method, static, and it is giving the integer index. So we are return type as integer, and then it is taking array. Okay, now what we have discussed, see what we have discussed here, that only we will replicate in the coding. What we have discussed, we will just create 2 method. Okay, and rest all is binary search. Okay, so rest all is binary search. Fine. So what is binary search? Int s is less than e. Okay, and we will calculate the mid element. What is start and end? So int s equals 0 and int e equals AR dot length minus 1. See, if you haven't watched my binary search video, then please watch it. I have created a complete dedicated video over binary search and explain this condition plus time complexity, everything. Okay, s plus e minus s upon 2. This is also I've explained. Okay, now the 2 condition we have discussed. If ARR of mid is greater than ARR of mid plus 1, then end equals mid, else start equals mid plus 1, not end, e we have taken, okay, and s. Why I have written else? Because see, there are only two conditions. There are only two conditions. If this got true, else this got true. So we need not to write explicitly like, okay, AR of mid less than mid plus 1. Fine. And then we are just returning s. Okay. So let's print it. Let's print. Okay, ready. Three. 0, 1, 2, 3. Okay, suppose let me write 8 comma, okay, and then Java application 4, 0, 1, 2, 3, 4. Okay, the same thing, very simple thing. Okay, now see the magic. See the magic. See, this is the solution we have write for one problem. Okay, now I will paste this solution in two problems which is of medium category and ask in Microsoft and Amazon. The problem which I ask in Microsoft Amazon, two different problem, and I'll the same solution. I'll paste same solution in both the problems. This is why this is the best DSA course. Okay, so let me copy it and paste it here. Okay, and let's create this method. Let's just which is passing ARR. Okay, we have saved it, ARR, and returning this index. Let's run it. This is in first problem. Okay, let's run it. Let's submit it. All test cases passed. Okay, let's copy the same solution in this problem. Okay, copy it and then nums. Okay, run it. Oh, okay. Return is missing. Run it. All test case passed. Submit. See, just one solution. Okay, and both the problems. So these are two problems asked in Amazon and Microsoft. Okay, and two different problems, okay, of medium category, and we have just written one solution, pasted in both the problem, and both got solved. This is why I'm telling you this is the best course, the DSA course. And we've started a new binary search problem series. So in that we are going to publish the hard and medium problems because it is the most important topic. Fine, so let's see in the next video.